In this example, we're going to look at how to calculate average rate of change from a graph. In particular, we're going to calculate average velocity, which is the average rate of change of displacement, and that's the type of graph we're given here as a displacement time graph. So we're going to complete the table that we see here on the right, and we're going to start with the interval from 0 seconds to 2 seconds, and our goal is to calculate the average velocity. So how do we do that? Well, we're going to plot some relevant points on our graph, the point corresponding to a time of 0 and the point corresponding to a time of 2. So the point corresponding to a time of 0 is right here, and for 2 seconds, we have our point right here. So I'm going to plot those 2 points, and I'm going to draw a line through them. That line is called a secant line. And to find the average velocity or the average rate of change of displacement, you can look at it either way, call it either or, we're going to find the slope of this line here. So how do we find the slope? Well, we essentially calculate the rise divided by the run for this line. And we have our 2 points that we'll use here. So we'll start by finding our rise, or our change in displacement. And how do we do that? Well, our second point has a displacement of 9. Our first point has a displacement of 0. So our change in displacement is 9 minus 0, which of course is 9. And then for time, we could look at the graph, but we also know we're talking about going from a time of 0 seconds to 2 seconds. So our change in time, that's our run, is 2 minus 0, and that's 2. So the average velocity will be 9 divided by 2, which gives us a velocity of 4.5 meters per second. And that is it. And remember, what that's saying is that if we were to make the journey from a displacement of 0 to a displacement of 9 meters, if we were to do that in 2 seconds at a constant rate of change, that rate would be 4.5 meters per second. The rest of them are very similar. So from a time of 1 second to 5 seconds, we can draw the 2 relevant points there. And we have our point at 1 second and our point at 5 seconds. We'll draw the secant line and we'll find its slope. So our change in displacement, that's our rise, is going to be 14 minus 5, and that's 9. And then our change in time is just 5 minus 1, which of course is 4. 9 divided by 4 is 2.25 meters per second. That is the constant rate that we would need to get from a displacement of 5 meters to a displacement of 14 meters in 4 seconds. All right, moving on. From 2 seconds to 8 seconds, we'll draw the 2 points, and hopefully you can look at this line and think about what its slope is right away. It's going to be 0. We have a displacement of 9 for our second point and for our first point, so our change in displacement is 0. Our change in time is 6 seconds. 0 divided by 6 is 0 meters per second. Now, what does that mean? Well, it pretty much means if you want to go from a displacement of 9 meters to a displacement of 9 meters over 6 seconds at a constant rate, just don't move. 0 meters per second will get you there. And for the final one here, we're going from a time of 2 seconds to a time of 9 seconds. Notice that when we draw that secant line, it now has a negative slope, so we're expecting a negative average velocity. And our change in displacement would be, well, our second point has a displacement value of 5, and our first point has a displacement value of 9. So 5 minus 9 is negative 4. And our change in time is 7 seconds here. So negative 4 divided by 7 is approximately negative 0.57 meters per second. That is our average velocity. And that is it. Some examples of how you can calculate average velocity or average rate of change in general from a graph.